All right then. Everyone, can you hear me?
Yes.
All right, thank you very much. Okay, so it's already 8 minutes past 11. We only have 53 people in the room. The whole class is about 75, right? So but I think I'm not going to wait for the rest. So we'll just start for the tutorial for today. So as you are probably aware, I hope you are probably aware that I've published the assignment. Um, I have published the assignment 1, right? Just share this with you. So I've published this assignment, the part 1 of binary classification with perceptron. And today, it's just going to be a explanation or a question and answer Q&A session about the assignment. Okay, so the assignment the date is 26th of April. There's a submission link via Google form on Spectrum. Yes, I already have updated it, right? And you are to submit a link to your collab notebook. Please, whatever you do, right, you can do it previously on your local machine or something, but at the end of the day, I like you to submit a link to collab, right? Because it's easier for me to mark your work. Okay, so in this assignment, you are to implement the perceptron algorithm with SGD or stochastic gradient descent, and this one you choose. Yes, number 2 you choose. You either choose batch gradient descent or mini batch gradient descent. So this assignment is inspired from V. Lee's introductory tutorial on deep learning. So this is his tutorial. So this guy is from Google, right? Google Brain, right? And he just if you kind of Google him, he's quite he's quite somebody. So this is a guy, right? So he did a back in 2015 tutorial on deep learning, right? Nonlinear classifiers and the backpropagation algorithm. So the background problem is somehow from here. right? And we have some explanation here. Here they are using some different notations. I don't really like using these notations because it's kind of messy. So I find that using a matrix notation is much cleaner, right? Else you have to have superscripts and subscripts everywhere, right? Instead of that, I prefer to use matrix notation. The notation in my notes and here is slightly different, but it means the same thing. It still means the same thing, right? Now it says using a stochastic gradient descent to minimize a function, right? So there is an algorithm, right? The algorithm is actually this one, right? And I've rewritten this in the assignment, right? I've rewritten this in the assignment as this. So this is actually uh, from this. Okay, so I've added a little bit more explanation here. So this is a problem. This is a assignment, right? You can do this, right? Using arrays, right? And some very few functions, just like the perceptron um, lab that we've done before, right? The and the or. So it's kind of similar. Not similar. You have more codes in here, obviously. You have more codes in here. Okay. Um, so the background problem is, of course, you are stuck in your room, right? You're trying to decide a movie that you would like to see, but you don't know whether you should watch the movie Godzilla or not. So you have a data set, right, of your friends Mary and your friends named Mary and friends named John's, and they have their ratings on a kind of movie. So this movie can be anything like Star Wars, Lord of the Rings, whatever, right? And then you have Mary's rating and John's rating, and it's something that you based on these ratings, whether you like it or not, right? But we're not going to use this data set. We're not going to use this data set, right? In fact, rather than giving you a data set, I'm asking you to create your own data set. Okay. So if you have, by creating your own data set, right? So you have y samples of yes and n samples of no class, all sampled from the normal distribution, the Gaussian distribution, right? Normal Gaussian distribution. And you choose the mean and the standard deviation, right? You yourself choose the mean and the standard deviation. Okay. And then once you've chosen the mean and standard deviation, and then you can create your own data set. For example, it's like this. It doesn't have to be like this, of course, right? It doesn't have to be like this. If you, for reproducibility, right? If you fix the random seed here, right? It will give you the same set of random numbers. So it's kind of a deterministic in a sense, right? If you seed your random generator. So the figures here, of course, you are expected to visualize this figure, right? Then you can have the training and test data, right? You can either split the training or test data, but since we are already creating the data set ourselves, you just need to create another. You just need to sample another data set from your own mean and standard deviation. Again, this is the algorithm using the stochastic gradient descent, right? You have to initialize the weights and the bias randomly, choose a learning rate alpha, pick a random example, and then compute the partial derivatives, update the weights, and repeat until you achieve some sort of convergence. And I've given a link to Sebastian Rashka website. So in this website, he talks about the different variation or different versions of gradient descent or stochastic gradient descent. You have the stochastic gradient descent. You have the stochastic gradient descent, the second version, and so forth. Right? You have the batch gradient descent and the mini batch gradient descent. So you have uh, three types of gradient descent, right? Stochastic, batch, and mini batch. Even for the stochastic, you have two versions, right? And even for the mini batch, you have two versions as well, right? So there's a bit, a lot of kind of a variation of the different approach there. So the idea of this assignment is for you to learn here. This is the point. Of course, how to update the weights using the gradient descent, right? And here you are only using the perceptron algorithm in a way because you are seeing the layer network. Your network is only single layer, right? As shown by code V lease. Just a moment, yeah. As shown by here. This is your network. You have the rating of your friend Mary. You have the rating of friend John. They are using theta. We are using W. So it's W1 and W2. And this is the summation and activation function. Because this is, yeah. And here is your output. Okay. I'm gonna pause for a while for any questions. Before that, there have been a few inquiries from students regarding the class on week 8, right? As you have known by now, the class on week 8 is face-to-face for tutorials, right? Face-to-face for tutorials, and but the lectures will still be online. So let me just take a survey here. I'm, I'm lazy taking a poll. I understand that there are students who, given the short announcement, right, by the management of the university regarding the mode of the class, right? So many students will be having difficulties in finding, renting a place in UM, right? Because it's just a very short notice, only about 4 weeks, 3 to 4 weeks left. So I'm just going to take a survey. Those who uh, uh, online online real. Yep. You get so those who prefer online tutorial, right? Because of your distance, maybe you're in Kedah, I don't know, in JB, probably, right? And it's difficult for you to find a place. But those who can come or who choose to come face-to-face tutorial, please click heart. Because I don't know whether I can make exceptions. Because if it's up to me, it's not a problem, right? If it's up to me, then if you can't come to physical class, it's not a problem. No problem. You can always join the online tutorial. So just wait a bit. Wait. Now. So can the rest of you respond as well? Yeah, we only have about 32% responding to the poll. That's about half of this class. Okay. So I've just changed the QR code on Spectrum for the attendance. So please scan your QR code for your attendance. Yeah. Please don't forget to scan your QR code for your attendance. So about 36 of you will be coming face-to-face tutorial, and 8 would be prefer the online tutorial session. Yeah.
Doctor, I think you reversed it.
Sorry? Oh, yeah. Did I reverse it? Those who choose to come to face would be oh, sorry, the other way around. Yeah. So those who are coming face to face will be about 8, and those who prefer online tutorial will be about 40 of you, about 39, 40 of you. 7. We have about 65 students, about 64, I guess, students currently in the room, right? Can the rest of you also respond to the survey? So overwhelming, we can see that overwhelming part of you guys, of the students who prefer to prefer on the for the online tutorial session. Yeah. All right. Okay. Just keep answering for those who haven't answered the survey, right? And back to the assignment. Any question on the assignment?
So basically, for the data of like the we just come up with the data with however many data we want randomly generated. Is that
You mean the data set?
yeah, the data set?
You have a freedom to choose the number of observations, right? So for example, you can choose yes to be 100, no to be 100. This is 100 and 100, right? You can use to be 1,000, but I think in the terms of thousands, and you can make it 10,000, doesn't matter, right? You can make it 10,000 for each class, or you can make 5,000 and 5,000, and then have a whole data set of 10,000. That's also fine, right? Doesn't really matter. But this one, what I'm showing is just for 100 for yes class and 100 for no class. Make sure there's some overlaps between these two. We want some misclassification happening here. So the difference there is a difference between stochastic gradient descent, right? So we're doing is stochastic gradient descent, right? This is a compulsory. You have to do the stochastic gradient descent, and then the second part, not the second part actually, the second part for the first part, it's a bit funny. You either choose a batch gradient descent or a mini batch gradient descent, right? So in this example, I've demonstrated using the batch gradient descent. As you can see, so there is a I've written the algorithm using the stochastic gradient descent. This algorithm is from this code release tutorial, which is about I think this part. This is the algorithm, right? And then for batch gradient descent or mini batch gradient descent, whichever you want to choose, you can find it here. Here, as you can see here, they're using a loss function instead of error function. The meaning is still the same, right? They're using the same notation: W for weights, X for inputs, Y for outputs, and D for data set, and B for bias, right? And here, I've also showed the output for, this is my output for stochastic gradient descent. And you have to show the change, how the error changes when when you are learning the algorithm. The algorithm is learning from the data, and then how, of course, the accuracy is is like the inverse of the error, right? So it kind of saturates here, and then you have the weights, how the weights are changing here, and then this is batch gradient descent. Batch gradient descent, slightly different, slightly, I guess, different figure than the stochastic gradient descent. And you have the accuracy also changing a little bit, and the weights are also changing. And these are the questions that I would like you to think of when doing this project, and visualize the plot line.
Doctor, I have one
Yep.
question. Regarding the
Yes.
partial derivative equation, if you can go back up a little bit. So the partial derivative equation is, I mean, for the stochastic gradient descent, doesn't the batch gradient descent use the same partial derivative formula, or is it use a different equation?
The partial derivatives, okay, for the batch gradient descent, right? As you can
Yes.
see, the derivatives for each training example is the same. Okay, the derivatives for each training example is same. For batch gradient descent, what you do is you're going to sum it um, over the whole data set instead of one, just taking one training examples, right? This is your error. This is the error, right? So you are summing the error for the whole training example, and then only you are updating the weights. So this is on GitHub. Yeah, this assignment is on GitHub. The references, I've put the references, the link of the references about here and here. Might be inside out. That's one. Yeah.
Doctor, so since this, uh, uh, I mean, Doctor, can you hear me?
Hello guys, sorry for that. It seems that my laptop has just restarted itself, so not sure what happened there. Just give me a minute to set it up again. So, where was I? So if you have any questions, please ask me again. Yeah. So the idea here, right, is for you to actually understand, right, and implement the gradient descent, and understand the difference between stochastic gradient descent, batch gradient descent, and mini batch gradient descent. Here you all will obviously automatically learn about the difference between stochastic batch and what is mini batch, and you will be learning about epoch as well. Yeah? EPOCH. What is epoch? So in this, for the stochastic gradient descent, I've used the term iteration because that's what been used in the tutorial. But for batch gradient descent and also mini batch gradient descent, you have epoch. For batch gradient descent, the epoch is very straightforward. For mini batch gradient descent, is the epoch is for every time it has iterated to all of your mini batches. So if you have 5 mini batches, right? If you've decided to separate your data set to 5 mini batches, right? And then only after the 5 mini batches have been looped over, then you count as one epoch. And then in part 2, okay, then you also have to compute the accuracy by class, right? In this example, I have the SGD, right? So obviously it's predicting a little bit better for the yes class rather than compared to the no class, but the batch gradient descent is not doing very good, right? Well, there's a reason for that, right? If you look at the results of the figure here, you'll know why isn't batch gradient descent doing as good as stochastic gradient descent, and you'll see the difference. This is why I want you to think of this, right? I want you to think of it. Why is this one smoother? Why is that? Which one converges faster? And things like that. And then part 2 is a very simple one. I just want you to vary your data set, right? And you just need to do it for one either SGD or BGD, right? And then just to change the mean and standard deviation. You go back here, you change the mean and standard deviation here, and you can also change the distribution. From here, we are taking this as a normal distribution. You can make it a log normal distribution or some distribution of your choice, right? Maybe a Poisson distribution or exponential distribution, doesn't matter, right? You choose. And then maybe you want to try with an imbalanced data set here. Means that in here, we have a balanced data set. The no class is about 100 and the yes class is about 100. You want to make it about maybe 200 for the yes and only no is about 100, or maybe 100 here and about 300 here. Doesn't matter as long as your data set is in balance. And then do the same. The rest is the same as part 1, right? You should produce the figures as this one. Batch gradient descent, stochastic gradient descent, the weights, how the weights changes according to the epochs or the iterations, how the accuracy changes, and how the sum square of error changes. Yeah? So do we have any questions?
Doctor, I have one question. Can
Yep.
you hear me?
Yes, yes.
Do we need to have the threshold? Because we use for the activation function, right? The sigma function.
Mm-hmm.
So the expected outcome is with the zero. Wait, Wait.
I see. That is the somehow the thing that I want you to think of as well. Yeah. Before by you know, doing this assignment. So in this assignment, the assignment, you know, comes from here. It comes from here. I just, you know, reorganize the assignment, you know, in a different way. But somehow the basic is here. The basic is here, and the algorithm. So the gradient is updated as this, right? This is the how the gradients are updated, and the gradients and the bias, the weights. Sorry, the weights are updated here with the gradients, right? And here is the bias as well, and you have some partial derivatives, blah 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 blah, and this is the equation, not the equation, the algorithm. So whether or not you have to, you know, implement the activation function, how do you implement it will be on how you understand the algorithm.
So it up to us lah to put the threshold or use something.
It is up for you to figure out.
Alright.
You see what
Thank
I
you,
mean?
Doctor.
Yeah, you'll see what I mean. When you do right, then if you are doing it wrongly, you'll see in your results. So any other questions? Seems that you are clear enough for the assignment. So maybe you ask me, Doctor, why are we doing this assignment, right? Because in deep learning, you know, you don't really have to do this kind of work, right? Well, maybe that's the point, because after this, right? After this, you will not be computing the partial gradients, partial derivatives, right? You will not be, you know, calculating the partial derivatives and computing the gradient. And even for the weights updates and the bias updates are done automatically. And even the initialization of the weights and the bias will be done automatically as well, right? So if you use Keras or TensorFlow or even PyTorch, right? Most of the process is has been automated, right? You just know how to write the codes, right? And how to design your network, and then you know how to make your network learn. But here we are doing it all manually because, you know, it's easier and it's more intuitive for you to understand it. So do you have any other questions? You can see the assignments on GitHub. Yeah. So if you have any questions, if you look for the assignment on Spectrum, you haven't found it, please go on to GitHub and see the assignment. Because the problem is if I put this link on GitHub, then every time I'm updating this, right, I'll have to update the link as well, which is a bit tedious, right? So I prefer for you just to refer here directly, so that I don't have to update the link. The reference are also given on Spectrum, but it's also given here, right? For the variation of the gradient descent and the assignment by code release, right? So in this assignment, in this tutorial, right, in this tutorial, there's a lot of discussion about the backpropagation algorithm. If you have time, have a look at it. How to debug the algorithm by numerical differentiation. We'll do backpropagation this week as well, right? And what are neural networks good for? This you know this, right? You already know this, but just to give you an intuitive, what does it mean? Some more intuition. What is the difference between the deep and shallow network, right? Sometimes your network is just as strong as a shallow network, and a brief history of deep learning, and so forth. So I think that's about it about the assignment, explanation on the assignment. If you have any questions, please ask me. If not, and if you're fine with the question, right? Please remember that the deadline is 26th of April, Tuesday, 2 p.m. Right? If you can submit early, but there are no extra marks for early submission. Just say you've done and dusted as your own reward, right? So if you have no questions, then I'll just end the tutorial officially. You may leave the room, but I'll just hang around a bit more if in case that some other students have questions. Okay.
Thank you, Doctor.
Welcome.
Doctor,
Yeah.
for the questions to ponder, do we have to answer that?
I prefer you to answer it.
Okay.
Okay. Because by answering this, it helps with the assignment.
Right. Thank you, Doctor.
Welcome.